Hello students, today we will study about differentiation of function. So it's a very interesting chapter and it is a part of differential calculus. So earlier we have studied about limits, continuity of a function, and we have seen that how to find the limit of function, what does limit of function means, and how to find the continuity of function. So today in this chapter we will study about what is meant by differentiation. We have already studied this chapter. I use this chapter in your physics classes, right? By finding out acceleration, velocity, right? But in this mathematics, we will study our differentiation in very elaborate manner, very extensive manner, and it's very important chapter for JEE, JEE Advanced. And so what is the differentiation? We also need to study about whether a function can be derived or cannot be derived. Like we have to check before differentiating a function that whether the function is differentiable or not differentiable. What is meant by differentiable? The differentiable means we need to check whether the function is derivative of function exists or not. Derivative of function means the differentiation. By doing the differentiation of a given function, we get derivative of that given function. Okay? So in physics we are studying about like the velocity. We write like dx by dt. Right? What is dx by dt? Small change in x. What is x? Distance. Right? Small change in distance respect to small change in time. So the rate of change of distance is known as velocity, speed. Similarly, when you write acceleration, what do you write? dv by dt. So what is dv by dt? It is depicting the rate of change of velocity with respect to time, and the change is very small, infinitesimal small. Right? So we could also write this as delta v by delta t. This is change in velocity upon change in time with respect to time. But when we write delta v in terms of dv, that means the change is very small. That's why we write d instead of delta. Okay, students? So differentiation in terms is very interesting chapter. So what do you mean by this thing? This is nothing but rate of change of velocity with respect to time. Okay, dear students. So, what is d by dt? This is rate of change of something, some function or something, right? Whether you see d by dt in something of dx by dt, dv by dt, or any other variable. So, what does that mean? That just means that the thing depicts rate of change of something. Okay, dear students. So before continuing, write down a definition of differentiation. What do you mean by differentiation? So write down the definition. Let y is equal to fx. Let y is equal to fx be a function. Let y is equal to fx be a function. Let y is equal to fx be a function. Then the instantaneous rate of change of y with respect to x. The instantaneous change of y with respect to x is called differentiation of y with respect to x. is called differentiation of y with respect to x. Okay, dear students. So we write differentiation of y with respect to x as dy by dx. Okay, dear students. And this can be also written as f dash x. If y is equal to fx, then dy by dx is equal to f dash x. We write it like this. You can also see somewhere like d of y. D of y means differentiation of y. So this is called derivative. And here x is known as independent variable. We have already studied this in functions chapter. I have told you that x is independent variable and y is dependent variable, right? So all of you have written the definition, right? Okay, students. So now, the differentiation, the term differentiation can be explained in two different ways. Okay. So first is physical meaning. What is the physical meaning of a differentiation? You will be studying this in physics classes, or you might have already studied this. So what is the physical meaning of differentiation? Instantaneous rate of change at that moment, like acceleration is dv by dt. At that given point, what is my acceleration? What is the change in velocity with respect to time? At that given moment of time is my physical value, is my dv by dt acceleration. Similarly, differentiation can also be explained as geometrical meaning. What is the geometrical meaning of differentiation? So, given y is equal to fx, let us suppose fx has some curve in a 2D coordinate plane. Y is equal to fx has a curve. So, at a given point A, x is equal to A. If I want to find out dy by dx at given point A, then what will you do by dy by dx? It will give the slope of that curve at the given point. Okay, dear students? The slope of tangent. So, what is the geometric meaning? Like, let's suppose I have a graph, I have a curve like this, and this is my point A. So, at that point, the tangent drawn, this is my tangent, and this is my slope theta. Okay, dear students, theta is the slope of that tangent at given point. Then the theta, the tan of theta, right? The tan of theta is what? Is dy by dx. So my slope is tan of theta. This is dy by dx. This is differentiation of y with respect to s at a given point x is equal to a. Write down this thing. So everyone understood it? Can you move ahead? So write down some important points. Write down the first point. Differentiation of a function. The derivative of a function. The derivative of a function is defined at the points where function is the derivative of a function is defined at the points where the function is differentiable. Function is differentiable. So all those points where my function is differentiable, only at those points I can find the derivative of that function. Apart from all those points, I cannot find the derivative of that function because the derivative doesn't exist. Why it doesn't exist? Because the function is not differentiable at those points. So what we have learned, the derivative of function is only exists at those points where the function is differentiable. So we will study about, we will try to find out the points where how to find out whether function is differentiable at some points or not. We will move on those two topics. So write down the second point. Write down the second note. A function is said to be differentiable. A function is said to be differentiable at x is equal to a. At x is equal to a if a function is differentiable at x is equal to a if a unique non-vertical tangent exists. What I am saying, a function is differentiable at x is equal to a only if a unique non-vertical tangent exists at the given point. What does that mean? So let us suppose there is a graph, there is a curve, and this x equal to a point, and I draw a tangent at this point. All right. What is the slope of this line? Yeah, the slope of line is 0. So what if I want to find the tangent at this point A? Tangent is like this, the vertical line. And what is the slope of the vertical line? Yeah, tan theta is not defined. So when the tan theta is not defined, the dy by dx does not exist. Why? Because the dy by dx is equal to tan theta. The slope of that curve at that given point is defined by dy by dx. But if my dy by dx, the tangent is not defined, then the dy by dx, the differentiation of the function, will also be not defined. And here tan theta is 0. So my dy by dx will always be 0. Got all the points? Everyone understood it? Can we move ahead? Alright. So, sir, you have discussed about differentiability. So, what is the definition of differentiability? So, write down our next topic. Differentiability. All right. So this is nothing but like you can define it. Just add on like this. This is just a process. This is what? Just a process to check whether derivative of function exists or not. Alright, this is nothing but a process to check whether a derivative of a function exists or not. Alright friends. Alright. So how to check? So let us suppose I draw a curve. This is a curve. This point A. Alright, so this is a curve, some curve, and I have pointed out 3 points A, B, C, and I have took some distance of h in x, where h is very small number. So, as I said that to find the derivative function, we need to check about the slope of a tangent. Alright. So, if I join these points A and B, and also A and C, so what will I get? I will get something like a chord. But you know that if there is a curve like this, and there is a line passing through it, the line is called secant. Remember this. This line, the line is called secant line. So the line is secant. What if I try to find out the slope of that line? So m of AB. What is the slope of that line? What is the coordinate of this point B? Tell me. Yes, this is a plus h, comma f of a plus h. What is A? Sir, this is A comma F. What is C? This is A minus H comma F of A minus H. So what will be the slope of AB? y2 minus y1 upon h2 minus x1. Remember this? The straight line, we have studied already this. So this is f of a plus h minus f of a upon a plus h minus. Alright, solving this we will get f of a plus h minus f of a upon h. So the slope of line AB is this. Alright, where h is very small. Alright. What if h tends to 0? Then the line, the secant line AB will convert it into tangent. So why I am trying to limit h to 0? Why? Because I want this secant line to be converted into tangent line. So what will I do? I will try to find out m of tangent, the slope of tangent, and I will limit the value of h to 0 in this m of a. So it will be f of a plus h minus f of a upon h, where h tends to 0. Alright, my students. Similarly, if I try to find out slope of AC, what is the slope of AC? What is the slope of AC? slope of AC will be y2 minus y1. That means f of a minus h minus f of a upon a minus h minus a, and that will be f of a minus h minus f of a upon minus h. Alright. Also, if I take this to limit f h equal to 0, this will become f of a minus h minus f of a upon minus h. Alright, students. And when these two lines will become a tangent at point A, don't you think those tangents will be equal? These two tangents will be equal, and that's why we call this is right hand derivative. Alright, RH, and this is left hand derivative, LH. Alright, friends. So when these two derivatives will become equal, only then my function, so y is equal to fx, will be differentiable at x is equal to a if RH यानी कि right hand derivative will equal to left hand derivative. Alright, if these two derivatives will become equal, only then I can say the function is differentiable. This can be written as f dash a plus, this is f dash a minus, and this is equal to limit h tends to 0, f of a plus h minus f of a upon h, and this is equal to limit h tends to 0, f of a minus h minus f of a upon minus h. So if by these two left derivative and right derivative will become equal, then the function will be differentiable at point A. What is the meaning of differentiable? It means the dy by dx at that given point will be defined. It will give something finite value. That means that the right derivative and left derivative should be equal. Alright, students. So thank you for this lecture. We will meet in the next lecture.